Now let's start off with an important concept of writing chemical equations, which is balancing the chemical equation. Now imagine you are sitting in a very boring lecture and you don't want to fall asleep. So what you do is you gather along your stationery, you have a pen, you have a ruler, you have one eraser and a few sharpeners. Now what you decide to do is you want to make a seesaw using these. So you keep a pen, you rest a ruler on it, and then you decide to keep the eraser on one side, and then you decide that you're going to keep a sharpener on the other side. But because the eraser is heavier than the sharpener, so it's going to tilt to one side and it just won't balance. And then what you do is, because you have another sharpener, you keep it on the first sharpener, and then you keep the third one. And that's when you see there is a certain movement and the ruler properly balances out like a seesaw would when you have two equal weighted people sitting on each side. Now the reason why this seesaw would balance, or the scale that you have made would balance, is because you have equal weight on each side, or equal mass on each side. Now, in the same way, you have to balance your chemical equations, because a Frenchman, Sir Antoine Laurent Lavoisier, in his law which he formulated, stated that we may lay it down as an incontestable axiom that in all operations of art and nature nothing is created. An equal quantity of matter exists both before and after the experiment. The quality and quantity of elements remain precisely the same, and nothing takes place beyond changes and modification in combination of these elements. Are you confused? Relax, I'll make it simple. This is nothing but the law of conservation of mass, which states mass is neither created nor destroyed. And when you have no mass created or destroyed, how can you have unequal sides? Therefore, you need to balance these chemical equations so as to have an equal mass on both the sides. Now let's look at a few examples of these and how do you actually balance these chemical equations. Now before we start with some examples of balancing the equation, there are a few rules that we need to register in our minds. Rule number 1, never reduce the number of atoms on either the product or the reactant side. Number 2, never change the subscript. Number 3, all you can change is the number at the coefficient. So with this said, we'll also talk about a format which will make our life easy in balancing this chemical equation. The format that we are going to follow is metal, non-metal, oxygen and hydrogen. That means first we are going to balance the metals, then the non-metals, then further oxygen and hydrogen. Now I do understand that oxygen and hydrogen are both non-metals, but over here we're going to give them a special status and treat them separately, which would make our life easy. Let's just consider the equation. Magnesium nitride reacts with water, gives magnesium hydroxide and ammonia. And as you can all see, that this is the preparation of ammonia. Now let's start off with the balancing of metal atoms. Now the only metal atom that I can see in this reaction is magnesium. Now on the reactant side you have 3 magnesium, on the product side you've got 1. How is it 1? Because at the coefficient position there is nothing, so that is automatically 1. And then what we have to do is, in order to balance magnesium, a simple thing, we have to add a 3 as a coefficient to magnesium hydroxide. Then let's move on to the non-metal, as we do not have any more metals left in this reaction. So looking at the non-metals, what we have is a nitrogen, and on the reactant side we have 2 nitrogen, whereas on the product side we have got 1. So a simple thing, as nitrogen is available only in ammonia, we are going to add a coefficient of 2 prior to ammonia. So by adding this coefficient we have balanced nitrogen too. Now what we'll do is we'll go back to the metal stage and cross check for any mistakes. Now magnesium, we've got 3 on the reactant side and 3 on the product side, well balanced. Then we've got nitrogen on the product side, which is 2, and on the reactant side, which is also 2. So this is also balanced. The next in line is oxygen. Oxygen is present in H2O on the reactant side and magnesium hydroxide on the product side. So let's just calculate the number of oxygen atoms first. We have 3 times 2. Now times 2 because this 2 is for both oxygen and hydrogen as it is placed outside the bracket. So 3, which is the coefficient for the whole compound, times 2, which gives us 6. So we've got 6 oxygen atoms on the product side, and simply what we're going to do is add a 6 on the reactant side to make it 12, to make it 6. Now the next and the last element which is to be balanced is hydrogen. So looking at the number of hydrogen atoms on the reactant side, we've got 12, as 6 times 2, we've got 12. On the product side, what we have is 6 in magnesium hydroxide and 2 3s are 6 on the ammonia side. So 6 plus 6 would give us 12. So hydrogen is well balanced. Now the final equation that we have is Mg3N2 plus 6H2O gives 3 magnesium hydroxide, which is MgOH twice, plus 2 molecules of ammonia. Now let's take another example. When you have a reaction of combustion of coal, when you have carbon plus oxygen, which gives you carbon monoxide. Now this happens when you have incomplete burning of your carbon containing substance. So now, as we do not have a metal, we would not take that stage, but we do have a non-metal, which is carbon. But if you look at the reaction carefully, carbon on the reactant side is 1 and on the product side is also 1, and hence you can say it is well balanced. Then we'll move on to the oxygen component. Now looking at the oxygen, we've got 2 on the reactant side and 1 on the product side. So now let's start off balancing the number of oxygen atoms. So simply what you're going to do is add a 2 prior to the carbon monoxide and you have a well balanced equation, but not yet. If you look at the equation carefully, you can understand that by adding 2 as a coefficient, you have imbalanced the number of carbon atoms. So now you have to go back and balance the number of carbon atoms. Carbon atoms on the reactant side is individual, so it's carbon plus O2. So what you can do is you can add a coefficient of 2 ahead of carbon, so the reaction becomes 2 carbon plus O2, which gives you 2CO, and hence we have a well balanced equation.